So the area enclosed in a square is just s squared, so the length of the side squared. For triangles, remember area is given by 1/2 times the base times the height. For a special triangle, the right triangle, so here's my right angle. In this case, if A and B are the legs of the right triangle and C is the hypotenuse, then the area is just given by 1/2 times the first leg times the second leg. I also want to remind you of the famous Pythagorean theorem. So that says if we have a right triangle, okay, and the lengths of the legs are A and B, and the hypotenuse has length C, then this relationship holds. So C squared is equal to A squared plus B squared, and so if we square the length of the hypotenuse, that's equal to the sum of the squares of the lengths of the legs. So just to do a quick example here, let's suppose I have a right triangle, and we want to find h, where h is just the hypotenuse. So the Pythagorean theorem is just saying that h squared is equal to 7 squared plus 10 squared. So h squared is 49 plus 100. So h squared is 149. And in this case, this tells me that h is equal to the square root of 149, which is about 12.2065 ... And notice I only take the positive square root because h, it represents a length, so it has to be positive. And if we round this to 1 decimal place, since there is a 0 to the right of the 2, that will be 12.2 units squared. Okay, so let's do the second example here, and we want to find b, where b is just this side right here. So again, I'm just going to use the Pythagorean theorem, which tells me that the hypotenuse squared is equal to the square of the sum of the squares of the legs. So we have b squared plus 4 squared. So this is 144 is equal to b squared plus 16. And that tells me b squared is equal to 128. Now I'm going to solve this for b, but I'm just going to take the positive root just because it's the length. It's a length, so negative wouldn't make sense. So b is going to be the positive square root of 128, 11.3137 ... And if I round this to 1 decimal place, I notice there's a 1 to the right, so I'm just going to leave this as 11.3 square units. So let's do some examples here. So in the first example, synthetic carpet costs about $3 per square foot. How much will it cost to carpet the following oddly shaped room? So here's the room right here. And it looks like it's a square together with a little part of a triangle. So let's first find the area of the room. So the square portion, so the area is going to be given by the square portion plus the area of the triangular part, so 1/2. And so we already know those formulas. So this is going to be 10 squared plus 1/2. And then the base, we can take this to be the base of the triangle, so we can leave that as a 10. What is the height of this triangle right here? So from what we can see, we know that this overall length is 16 and this is 10. So the height of the triangle is given by 6. And now adding this up, I have 100 plus 30. So 130 square units. That would be the area of the room. And so if we want to carpet the room, we have to pay 130 times $3 for each square foot, and we end up with $390. Here's another example. You need to reach a window that is 15 feet high, but you must place the base of the ladder 9 feet away from the wall for safety. What is the shortest ladder that can reach the window? So for problems like this, I would recommend drawing a picture. So let's suppose that here's just the house, and let's say the window is located here, and here's the ground. So we know that the window is 15 feet off the ground, and we know that the ladder has to be 9 feet. The base of the ladder has to be 9 feet away. So let me just draw the ladder. So the house and the ground form a right angle, so we can see that the ladder really is just the hypotenuse of a right triangle. And so in order to find the length of the shortest ladder, we will take c squared is equal to 15 squared plus 9 squared using the Pythagorean theorem. So c squared is 225 plus 81, which is equal to 306. So solving for the positive square root, we have that this is equal to 17.49 ... which is, if I round this to 1 decimal place, since there's a 9 on the right, I'm going to add 1 to this guy. So this is about 17.5 feet. So that is the shortest ladder. Okay, just a couple more examples. Ship A leaves a harbor and sails due east at 20 kilometers per hour. Ship B leaves the same harbor and sails north. After 3 hours, the ships are 75 kilometers apart. How fast was ship B traveling? So again, this is kind of like, I'm not sure what's going on. I'm just going to draw a picture that helps. It's going to help me. So let's go back. Ship A leaves a harbor. So let me just draw a point that represents the harbor. So ship A is going to sail east. That's in this direction, and it's going to go 20 kilometers per hour. And we know it's going to go for 3 hours. So 20 kilometers per hour, 3 hours. So it's going to travel about 60 kilometers in distance. Ship B is traveling, let's see, north. So it's traveling in this direction. Again for 3 hours, and we don't know how fast it's going, but we know that after 3 hours, my two ships are A and B are 75 kilometers apart. And so the question is, how fast was ship B traveling? So we know ship A traveled 60 kilometers, and this is unknown. However, traveling east and north gives me a right triangle, so I can actually figure out how far ship B traveled. So again, I'm going to use the Pythagorean theorem, and we know that 75 squared is equal to 60 squared plus, let's call this distance b, b squared. And if we solve this again, we have 5,625 is equal to 3,600 plus b squared. So b squared is equal to 2,025. And this gives us b is equal to 45 kilometers. So we know b is 45 kilometers. And if it traveled, and let's assume these all are traveling at a constant rate. So assuming it is traveling at a constant rate, ship B traveled 45 kilometers, 45 kilometers in 3 hours. So how fast did ship B travel? That's 15 kilometers an hour, assuming a constant rate. One last quick question. Find the length of ED. So that is this guy right. So that is this guy right here, ED. Given that EB has length 13. So EB is this distance right here. So we need to figure out the ED. So how can we do this? So what I'm going to go for is to try to find the length of segment DB. If possible, because then I can subtract that from 13 and get ED. So can we find the length of DB here? And it looks like this is a right triangle, so we're in luck. And so what I have is c squared equals a squared plus b squared. And in this case, we know the hypotenuse is 5. And one leg is known. And so let's call this side b. And so we have 25 is equal to 9 plus b squared, or b squared is equal to 16. So b is equal to 4. So we can actually find the length of this side, and it's 4. So that tells us that the length of ED, if the total length is 13 and this length is 4, then the length of ED is 9.